So hello and assalamualaikum everyone. In this video, I will explain 3 questions that have been requested. Okay, so question 14B, 17 dengan question 21 yang memang saya perlu explain lah. So the first question is question 14B. So I will explain the question based on the working solution that I have done. Okay, so arahan kata find the vertical and horizontal asymptotes of the following function. Hence, sketch the graph of the functions. Okay. So for vertical asymptote, as usual, we are going to take the denominator over here and we make it equal to 0 like this. Okay, and then kita akan dapat dua nilai lah, x equal to 1 dengan x equal to -1. Okay, so these are the possible values of vertical asymptote. So now we need to test either these two values are our vertical asymptote or just one. Okay, so dekat sini madam rasa awak tak ada masalah untuk dapatkan dia punya jawapan. Right, so just be careful over here. So when we substitute the value of 1 directly, okay, so substitute 1 first directly without the sign, ignoring the negative sign dekat atas satu tu. So awak akan terus dapat 1/0. So 1/0 is the case where you need to test the value of 0 that you have down here, either it's positive or negative. Okay, so kita akan ambil nilai 1 negative. 1 negative means that 0.9 lah. So 0.9 substitute dekat dalam this one. So kita akan dapat 1 minus 0 something, which is 0 positive. Okay, and then positive divide by positive, we have positive infinity. Okay, so itu sahaja untuk bahagian vertical asymptote. And bila kita buat dua-dua, awak akan dapat from the left of 1 we have positive infinity, from the right of 1 we have negative infinity. Okay, and then for negative 1 from the left awak dapat positive, negative 1 from the right awak dapat negative. Okay, so vertical asymptote kita ada dua nilai lah. Right, and then for horizontal asymptote, so horizontal asymptote macam mana kita nak cari? Kita akan cari x approaching negative infinity as well as x approaching positive infinity. Okay, when we substitute the value of infinity into our function, into our expression from here, so kita akan dapat negative infinity ke atas ni. So negative infinity over infinity, and then nampak je infinity over infinity. This is the case where you need to divide by the highest power of denominator. Okay, so highest power of denominator means that just take a look at your denominator down here. So the highest power is x squared, so we are going to divide every term that we have inside the fraction with x squared. Okay, bahagi x squared, bahagi x squared, bahagi x squared. Then simplify like this, and then just imagine you substitute the value of negative infinity into your x. Okay, you cannot write the substitution. Okay, so remember you cannot write it like this. Okay, jangan masukkan dia macam ni. Just tulis hasil sahaja. This one hasilnya adalah 0. This one hasil dia pun adalah 0. So jangan buat macam ni lah. Okay, so kita akan dapat jawapan kita 0. Okay, so kena test dua-dua. So and then from x approaching positive infinity pun kita akan dapat 0 juga. So horizontal asymptote kita ada satu sahaja lah, y equal to 0. Okay, so now moving on to graph sketching. Okay, so untuk graph sketching dekat sini saya dah listkan dah dekat awak. Okay, so vertical asymptote kita is x equal to 1 dengan negative 1. Horizontal is just y equal to 0. Okay, and then list all the limits that you have over here. Okay, so 1 from the left, 1 from the right, negative 1, negative infinity, positive infinity. Okay, so dekat sini, nilai yang awak dapat dekat sini sangat-sangat penting. Okay, so that's why kena berhati-hati bila kira sama ada kita dapat infinity, negative infinity ataupun kadang-kadang boleh dapat undefined ataupun nombor. Okay, so I've labeled the asymptotes over here. So let me just label the horizontal asymptote. Horizontal is exactly at the y-axis over here. Okay, sorry, x-axis. Okay, so this is y equal to 0. Alright, and then let's moving on to draw the arrow. Okay, so for the first limit, 1 approaching from the left. Okay, so this is 1. Left part is this one. Okay, so you can see over here that your y is approaching to positive infinity. Positive infinity means that it's going up. So we draw an arrow over here. Okay, and then 1 positive. 1 positive is the right side over here. So your y is going down, negative infinity. So the arrow is going down. Okay, and then next one. So negative 1, negative, positive infinity. So it means that on the left side of negative 1, it's going up. Okay, and then negative 1 from the right, it's going down. Okay, so it's over here. Okay, last two. Right, and then negative infinity. So x approaching negative infinity means that it's going to the left part over here. Okay, left part over here. And then you can see that your y approaching 0. Y approaching 0 means that it's approaching this line. Okay, so it can be from here. It can also be from here. Okay, so we draw the arrow on top and down here. Okay, and then x approaching positive infinity. So positive infinity is going to the right over here. Okay, so it's going positive, positive, positive. And then y is approaching 0. Approaching 0 means that approaching the line x-axis, y equal to 0. So the line is up here and down here. Okay, so now we are going to connect the arrow that is not intersect, yang tidak melanggar awak punya asymptote. Okay, so contoh dekat sini, this one. Okay, kita nampak dia ada arrow ke atas kan. Okay, so maksudnya dia boleh dilukis, boleh jadi macam ni. Okay, tapi boleh juga jadi macam ni. Tapi kita tak akan ambil yang this one. Sebab apa? Sebab this one melanggar awak punya asymptote yang warna oranye. Okay, so dia mesti arrow yang tidak melanggar asymptote. So this is your asymptote, this is your asymptote, hence the line will be like this. Okay, so that one is gonna be like this. Okay, so this is our first section of graph. Okay, and then what else do we see? So, okay, so this one. So we see this one going to this one. Okay, like this. Okay, and then there is another one line, one segment that you need to draw. Okay, so we see in the middle over here, okay, in between your vertical asymptote over here, so we have one arrow going down, and then we have one arrow going up here. Okay, so means that mesti akan ada satu line lah, satu line yang menurun ke bawah macam ni. Okay, so cuma kita tak tahu dia datang daripada mana. And then yang ni pun sama, dia mesti ada satu line juga yang naik ke arah dia. Okay, tapi kita tak tahu dia datang daripada mana. Mungkin dia boleh bersambung dekat sini kan. Okay, so apa yang kita boleh buat over here is we can clearly see that it might have a y-intercept as well as x-intercept. Okay, so kita cari dekat sini. Let's say saya cari y-intercept. Y-intercept is when x equal to 0. Okay, so what is our function? Okay, so this is our function. So x0 means that kita akan dapat y equal to 0 over 1 minus 0, which is equal to 0. Okay, this is our function. Substitute value of 0, kita akan dapat 0 lah. Okay, so x0, y pun 0 juga means that dia intercept betul-betul pada origin. Exactly dekat origin kita sini. Okay, so means that graph kita dia akan jadi macam ni and bersambung ke bawah. Yeah, this is our graph. Okay, yang dekat tengah-tengah tu. Okay, contohlah. If let's say, kan kata kita ada horizontal asymptote. Horizontal asymptote kan kita tak boleh langgar patutnya kan. Okay, so there is another meaning, another definition for horizontal asymptote. This one. Okay, recall balik cara kita cari horizontal asymptote macam mana. Okay, saya besarkan kat sini. Okay, so this is how to find horizontal asymptote. So kita nampak bila kita punya x approaching infinity, okay, and then value of y kita akan approaching to a certain value. Maksudnya dia approaching infinity, value of y approaching 0. Okay, and then satu lagi x, infinity kan. So infinity approaching infinity, y approaching 0. And then x approaching negative infinity. So dia ke belakang, y awak menghampiri 0. So betul lah maksudnya. Itu adalah maksud sebenar for horizontal asymptote lah. Kita nampak kita punya graf tu ke belakang dan makin menghampiri asymptote. Okay, ataupun dia ke depan dan makin menghampiri asymptote awak. So that is the meaning of horizontal asymptote. So bila langgar dekat sini tak ada masalah pun sebenarnya. Okay, let's say awak macam confused, awak macam masih lagi tak nak terima kenapa dia langgar dekat sini. Okay, why don't you try to substitute back the value of 0 as well as y over here that you have into your function dekat sini. Okay, let's say kita masukkan 0. Masuk 0, masuk 0. Kita akan dapat 0. 0 adalah number lah, dia bukan undefined. Ataupun kita masukkan 0 dekat sini. Dekat kita punya subject. So 0 equal to x over 1 minus x square. So kita akan dapat terus x equal to 0. So x equal to 0 adalah number, dia bukan undefined. So bolehlah, tak ada masalah. Okay, so yeah, that's it for our graph. Okay, so moving on to question number 17. So you are given a function fx equal to square root of x. Okay, so madam suka kalau macam nampak dia punya square root ni terus macam dalam kepala. Okay, so kita tahu dalam kita punya modulus dia mesti greater than or equal to 0. Okay, whatever that is inside the modulus, in this case adalah x, dia mesti greater than or equal to 0. So ini number line kita lah. So kita punya domain start from 0, 1, 0, 0.0001, 1, 2, 3, 4, 5 and positive infinity. Okay, so dia cakap kat sini explain why f is discontinuous at x equal to -1, x equal to 0. Okay, so recall balik definition of continuity. Okay, condition of a continuity at a point. Okay, untuk kita pastikan, untuk kita tentukan either the function is continuous or not at a certain point given by the question is, kita kena tengok dekat sini lah. So the first one, kita mesti cari dia punya fc. Okay, FC define ataupun tak define. Okay, so untuk 17 at x equal to -1, for the first value x equal to -1, bila kita substitute kita punya FC, kita sekarang nak buat condition yang pertama. So f -1 lah. Masukkan -1 dalam function awak. So kita dapat terus square root -1, which is automatically undefined. Negative cannot be inside a square root. Okay, so daripada sini tak perlu cari nombor 2, tak perlu buat nombor 3. Nombor 1 pun dah tak satisfy, ini kan pula yang nombor 3. Okay, so terus cakap since f -1 is undefined, fx is not continuous at x equal to -1. Okay, next one. So, dekat x equal to 0 pula. So, at x equal to 0, first kita cari dulu FC kita. So, FC is F0. So, square root 0, terus dapat 0. Okay, 0 tak ada masalah. Dia adalah nombor. So, dia define lah. Okay, so nombor 1 settle. So, continue to number 2 pula. Okay, number 2 kita nak cari limit kiri kanan. Exist ke tak exist? Okay, so, now kita cari limit kiri. So, limit kiri, saya buat limit x approaching 0 from the left fx. Oh, kenapa jawapan dia terus undefined? Okay, sebab dari macam ni. So, kalau kita bayangkan kita punya graf kan, graf awak tu, graf apa nama dia? Square root kan? Square root of x kan function kita kan? Okay, square root x. Graf kita dia akan bentuk macam ni. Okay, so this is our graph. So, this is square root x punya graph. And then dia dekat origin. Starting point is at origin. Okay, so kalau dia kata dia nak x approaching 0 from the left. 0 from the left maksudnya graf yang datang daripada kiri kosong. Kosong kat sini. Kosong kat sini. Ini kosong. Okay, daripada kiri. Ada tak graf di sebelah kiri sini? Tak ada. Okay, so bila tak ada, dia akan automatic jadi undefined lah. Sebab there is no graph from the left. Okay, there is no such graph from the left. Right, so that's why kita akan cakap since limit x from the left is undefined, so dia bukan continuous dekat x equal to 0. Okay, that's why. Right, so untuk graf ni dia lain sikit lah. Sebab memang kalau kita substitute value, kan biasanya dekat sini awak akan substitute awak punya function. So substitute x. Okay, lepas tu terus je masuk nilai kosong. Memang kita akan dapat 0. Cumanya sekarang kita consider dia punya bentuk graf juga. And then kita bayangkan juga daripada kiri, kalau tengok pada domain awak, okay, look at your domain over here. Domain yang kita dah lukis dekat sini tadi, graf kita bermula daripada kosong dan ke kanan. Tak ada pun daripada kiri. So kalau 0 negatif, memang that's why dia jadi undefined lah. Okay, settle. Next one. Okay, so for question number 21, dia kata kat kita, find the values of A and B if fx is continuous at x equal to 1/2. Okay, so nampak je continuous, so kita akan terus buat this statement lah. So kita tahu f1/2 is equal to limit from the left 1/2, limit from the right of 1/2. Okay, and then kita akan cari satu persatu lah. So untuk nilai A, madam menggunakan formula daripada this one as well as this one. Okay, sebab apa? Sebab kita nampak A duduk dekat sini. Okay, and then dekat sini dia adalah 1/2. 1/2, okay, 1/2 to the left means that kita boleh cari nilai limit daripada kiri lah. Okay, and then lepas tu kita gunakan yang ini. Sebab yang ini dia tak ada apa-apa unknown. So dia hanya 4 sahaja. So ambil yang ini, terus boleh dapat nilai A. Okay, so yang ini adalah exactly dekat x equal to 1/2. Okay, that's why kita pakai f1/2 dengan limit from the left. Okay, boleh kalau nak guna yang ini dengan yang ini, tak ada masalah sebab diorang kan sama kan, cuma dia tak membantu awak untuk mencari unknown lah. So kita kena fikir cara lain. So kita kena kurangkan kita punya unknown di dalam equation kita. That's why I'm using this one and this one for this one. Okay, and then seterusnya nak cari nilai B, saya gunakan pula yang ini dengan yang ini dekat sini. Yeah. Okay, so the value of A, I think you don't have any problem over here. Okay, so I want to focus at this part dekat sini. Okay, so bila kita gunakan equation yang this one, function this one untuk cari nilai B, so you will have this one. Okay, so normally I will tell you to define the modulus. Okay, memang saya cakap kat awak, saya pesan dekat awak, kalau nampak je modulus, kita terus define dia. Okay, terus define dia. So modulus define dia akan jadi 1 plus bx, satu lagi negative 1 minus bx, and then dekat belakang awak terus dapat x is greater than equal to negative 1 over b, and then x is less than negative 1 over b. Okay, ini betul kalau kita tak ada unknown, but in this case we have unknown inside our modulus. Okay, kita ada unknown b, so bila nampak je ada unknown, you don't have to define. Okay, buat nota dekat dalam awak punya tutorial tu nanti, no need to define when there is unknown inside the modulus. Okay, kalau ada unknown tak perlu define, kalau tak ada boleh define, memang kena, wajib. Okay, so kalau untuk soalan yang ini, apa yang kita akan buat adalah awak ambil je dengan modulus tu sekali dekat sini. Lepas tu, kita masukkan je value of 1/2. 1/2 masuk dekat sini. Okay, so sekarang kita ada dalam bentuk macam ni. Right, and then what we are going to do right now is just to solve absolute equation. Okay, so solving absolute equation macam dekat dalam chapter 2. So apa yang kita buat, dia akan jadi dua lah. So the first one is positive, second one is negative. Sekejap, negatif ni Miriam tukarkan dia dekat bahagian depan. Negatif, macam tu. Okay, so satu function positif, satu function negatif. And then solve je macam biasa, so dapat two values of b. Okay, so itu sahaja, right? So remember for question number 21, if we see a unknown inside modulus, we don't need to define. Okay, tapi contoh kalau dekat dalam modulus awak tu kita ada macam ni, 1 minus 2x plus k. This one, kalau yang ni perlu define tak define? This one perlu define lah, sebab unknown dekat dalam ni tak ada. Okay, dalam modulus tak ada unknown kita dekat luar, so this one still kena define. Alright, okay, so okay, that's all in this video. Right, so if you have any question, you can just ask me. Bye bye.